transition from there to there, and that's not meant to scare you, but we think we're seasoned and not over the edge. But yeah, real quick, I'm Randy George, coming up from Austin, Texas. So I appreciate the nice spring weather. And I've been doing like Joydeep and I now work at Red Hat about 3 years ago, maybe a little more than 3 years ago. Our whole project moved over to Red Hat from IBM, and it was part of just portfolio shuffling, right? And we were doing observability then. And I've been doing project management stuff. I was thinking about it a little over 20 years, and observability close to about 15 years, right? Different aspects. So we can go back as far back as you want, answer questions that you want, but we're going to try to focus more on the last couple of years of what we've been seeing. But Joydeep, want to introduce yourself real quick?
Yeah. When Randy was doing his master's, I was born then.
Yeah. My thesis is chipped in stone, but yeah.
How many of you have heard of Beatles? Not you students. How many of you have heard about Beatles? So that shows. Okay. So I was telling Randy, a couple of days back when I saw this, I was reminded of the fact that there's a Beatles song. Beatles famous album called Sgt. Pepper.
Yeah, every year.
Okay, all right. So it's wonderful to be here. It's certainly a thrill. Honored to be here. So yeah, apart from the Red Hat ACM stuff, I've been dealing with, and a lot of it is shared time with Randy, by the way, dealing with building observability tools in IBM and in Red Hat. Then that's one part. The other part is trying to, in a software company like IBM or Red Hat, trying to manage the software that we build, trying to run it in cloud. So there we are staying at a slight distance from the observability tool, trying to see how we can manage it. And the third part is actually working on a customer, what we call as real customers, working on bringing their stuff to microservices and cloud and managing them. Then you get a totally different perspective of, okay, what are these vendors? What do these vendors do? What do they promise us?
What's this thing keep going out?
Oh,
I don't know what. I never had that
so
earlier.
we hope that, we can bring that experience in and help to talk about the forest from the trees, but make it interactive, please. We are not
It's not-
making it
laptop's
up. So
not going to
if there are
sleep,
no
is that?
questions, we fall asleep.
Yeah, I think she switched adapters. I wonder if that's missing a wire to keep detecting. This is twice now. That's falling asleep. Apologize. No, laptop's not falling asleep. It's
Yeah, laptop is,
alive.
yeah,
So, anyway,
okay.
yeah. See if this. So real quick, I think you read this in the topic. That's the idea we want to give you. We want to kind of get you to think. Sorry about that. We're going to talk about where some of the challenges are that we see with customers in the real world. Also, what I'm seeing, one of Heidi was mentioning, one of my new challenges faced with helping improve the SREs in Red Hat that are supporting our cloud hosted services. And
We don't know what it's.
oh, sorry. Basically,
Site reliability.
site reliability engineer, but they may not know what that even means.
Yeah,
Think about it as kind of an operations person in the cloud, but the big difference is the operation person has an engineering mentality, even background, maybe. They're not scripting, which is all IT typically knows how to maybe script it most, right? And they don't think like programmers, where SREs tend to think more like programmers, and it changes the mind shift quite a bit on how you approach things, right?
right. And so, sorry, I mean, they are also architecturally focused. They understand the architectural details. They want to build resilient systems. And their concern is the things they monitor is typically is my end user happy. That's what they do.
Yep.
And as Randy said, the major thing is it's a change in mindset. It's a total change in attitude. You look at the thing in a different way.
And we tend to be full stack with that. But so real quick, we decided to take a slightly different approach at this from an agenda. So you're not going to see like 20 slides, Randy pitches, and then turns it over to Joydeep pitches 20 slides. We technically have 3 slides, one's broken up a little bit. That's it. And we're just going to talk, answer questions, but give you our perspective. And since, like we said, we both have it, so this isn't canned presentation that much. Hopefully it works out well. And we'll see, but we're gonna give you a little bit of context. Anybody that does monitoring understands context is important. Just seeing a graph and, all right, yeah, you're driving this fast. Well, driving 55 miles an hour. Okay, is that good, bad, or indifferent, right? Yeah. That's never too early.
And so you go to DevOps, the same thing, but with buzzwords.
So- Are they buzzwords? They are buzzwords, but yeah, but they're well accepted buzzwords. But so DevOps to me is a process where an SRE is a role. Okay. So DevOps is bringing together the development and the operations and unifying and usually having a automated, consistent pipeline for code development, CI/CD pipeline, code development, deployment, and the SREs are involved with usually like a staging environment that simulates or tries to emulate production as much as possible to go through some of that testing, even backup restore testing or deployment type testing, et cetera, push into production, right?
Yeah, it's funny that you mentioned while flying here. I was listening to a podcast from SE Radio, Software Engineering Radio, and they were interviewing a guy about SRE and DevOps. Yeah, Randy kind of said it. DevOps is slightly on the left-hand side, and SRE comes towards the end. If you ask me from my personal experience, I forget the name of the director from Netflix. Back when Netflix moved 2010, when they moved from data center to Amazon, at that point of time, he made a statement which doesn't appear in the internet anymore. At least I could look it up. The best way to get engineers into this mind shift is, okay, you build it, you own it, but basically make sure that they are on the call, they are on the hook if something goes wrong. Trust me, just as the SRE thing Randy said, you think about things in a totally different way. If you have to, you're enjoying relaxing your Friday evening or your Saturday morning or whatever, you get a ping and you've got to jump in right there and you've got to solve a problem, clock is ticking. It is a totally different mindset. And you do it 2 times or 3 times, from then on, you will make sure your software is written in a different way so that you don't have to face that hassle. Right. Normally what happens? We throw it over the wall. Okay. Call goes to Heidi. I have written the stuff, it's for her to.
Yeah. And it's, yep. So anyways, real quick, we're gonna go challenges. We're gonna talk about what Red Hat does today, give you and some of those customers. And I think you'll be surprised at how immature the industry is. And then we have a scenario we want to kind of take it through that maybe we'll do a little thought provoking too, but some where research to be applied, right? So real quick context. So context is important. Want to make sure you understand when we answer a question where we're coming from, right? Because they're born into cloud companies that do things quite differently, et cetera. We're talking to customers that have multiple clusters, multiple Kubernetes clusters, not just one, not just 2. And so it's a different set of customers. Larger customers are that's what we talk to, large, medium to large enterprise customers. Oh, what is this thing doing? It's crazy. I didn't have that problem with the other adapter. I might have to move back the other adapter.
So are those, well, he's figuring it out, so
It just
how
happened.
big are those questions? How big are them?
They vary greatly. So for example, there's a customer we're working with, which not to mention any names, but you might have a phone by them or a watch by them. They have 1,000 worker nodes on one of their clusters. Okay. So they're on the mindset, I want these big clusters, right? Then there's other companies that are like, no, I'm going to run one app per cluster. And these apps tend to be smaller. And I mean, I've seen them go 10-ish worker nodes, a lot are 25, 50. So it varies in that range. I'm going to say probably 1,000 is the largest I've seen in production, and the 10-ish, 8, and that's a worker node stack. Yeah.
Yeah, I mean, are you mentioning 1,000 clusters? The worker nodes probably is around about 250 or 500, right? Have you seen 1,000? I think it's probably
I have.
Okay. All right. Okay, so back to this stuff. I mean, at one point of time, it was very hard to install clusters, upgrade clusters and stuff like that. So people went to that big stuff. And now OpenShift has made it so much more easier that we are actively encouraging people to go for smaller ones. Right. And then in the edge, of course, it's ultimately
In fact, Yeah, to answer questions, so I kind of was misleading saying I've seen from this range to this range. So now we're starting to see with Edge, like you said. Working with telco, for example, that's pushing Kubernetes or OpenShift out to the edge of their network, right? And operating the virtual DU in 5G, if anybody doesn't know what that is. Basically, go look at a cell tower somewhere. There's a physical machine there tied to the cell tower, getting the signals coming from the antennas. They're processing the signals. They have a Kubernetes cluster in that box.
And Randy, back to the device stuff that you are working, that's,
Yeah.
there is no cluster, that's a device.
Operational, yeah, really good example. So build a solution. We have customers doing, factory, right? They have cameras analyzing, let's just take boards coming across looking for soldering defects, right? And these cameras are analyzed and they have AI going against it, flagging bad or not, right? And that's small Kubernetes with some phones attached, running and analyzing as the boards go by, sending data back up to have the model continuously refine in an ML perspective.
So you mean that the telecom deployments are smaller, so can you give some example, like how many clusters and usual telecom?
Well,
No,
they're just in this early phase, okay? But if they're successful and continue to roll out, or I should say when they're successful and continue to roll out, you're probably looking in 150,000 clusters range. Edge, some of the edge, what we're seeing in the factory, and in fact, we're also talking with some of the automobile manufacturers that are looking at this. We're probably talking near 1 million.
Yeah.
Per.
1 million clusters, so these clusters are,
Devices.
how many
smaller.
physical, so how many physical computers are in that device?
So the one on the telco right now is a 4 CPU, hyper-threaded, so you could argue it's 8. The ones I've seen in the devices tend to be 1 to 2 CPU max.
They're running a Kubernetes cluster on that one computer.
Yep.
Why-
It's a single
why we're
node.
Just like, we're just using containers straight, why have a?
That's, we could spend the whole rest of the day on
Yeah.
that discussion. I have some of the same questions as well, right? Now, Podman's come a long way. Container doesn't have all of the same compatibility as Kubernetes, for example. I think it just picked up getting the ability to handle secrets didn't before. But if you look at the studies out there, the fastest growing from a development sector, the edge programmers, and they call them fog programmers too, that deal with it right behind the edge. Kubernetes is now 2/3 to 3/4 of all developers are doing Kubernetes for edge.
But
Crazy.
Sorry, I'm just.
Well, I can answer that question.
Yeah.
Because it gives you a standard API for defining the components of your application, or defining what storage it attaches to, how it gets configuration, where it gets credentials from. And whether you're running on a small device or whether you're running on a big cluster or an Amazon or GCP somewhere, you have the same API that you're working with.
Yeah.
That's why people are.
The
And
portability of
when you have a huge number, then the management becomes very challenging. I mean, we were surprised that what people were asking, we thought about, I mean, this is related to advanced cluster management. Customers were asking for a feature, which we thought, that's very dumb. Why do you need it? The answer is simple. When you have 5, 10, 15, 20, 50, those things become very hard to do otherwise. Back to the standardization. And telco is not monolithic. You have the VDUs that Randy talked about, which are on the cell towers. And then there's what's MEC, the multi-access edge computing, where the real, where very, very rocket sciencey stuff are going on, where they're really looking at the data traffic that's going. Let's say we are playing a game, they are doing things out of there. So that's another stuff. So all of them are operating clusters. Back to the point you made, Michael. They want to have uniform APIs to control all of
The
them.
one behind me.
I'm sorry. Yeah.
But Michael's taking credit for. But actually, to go back to your comment, I say about 150,000, that's what I'll call traditional cells, right? What's coming up quickly is the concept of small cells in 5G. And these are really small devices. In fact, you go into urban areas, could be downtown Boston, downtown New York City, whatever. And they'll slip them under manholes covers even. So those are really small devices. That makes the number even go much higher. But I haven't seen and working on that at this point, right? With Kubernetes, that is, right? But still proprietary hardware implementations for that. Okay. The other thing to keep in mind, people we talk to tend to be infrastructure operators, right? Not the app owner itself, right? So that gives you a slightly different perspective. Now, with that said, sure, we're talking to some of the Red Hat cloud operations where they deploy a Kubernetes cluster as a service. In essence, that is an app, right?
That's
From that perspective. So there's a little bit of an app, but just keep in mind, I mean, we're coming up from a cluster, from a VM, from a server perspective. Those are people we're talking to.
And we are not talking to people like Meta, who are
Right.
extremely mature. We are talking to people who are, in a journey. Okay, you.
He's talking about that after.
Yeah.
Okay. All right.
But those, a lot of those customers tend to be, you mentioned Netflix, they're using proprietary stuff, right? Because a lot of the commercial stuff doesn't scale, meet their needs,
It doesn't.
move fast enough, et cetera, right? So that's on the context. So this is one of the few charts. We could talk all day on this one, but we want to kind of give you an idea of some of the challenges. And when I say monitoring, keep in mind, that's not metrics, it's metrics, logs, trace data. And that's what the classic observability, Joydeep and I like to add events to that. We think events are actually more important. Somebody will argue, well, a log is nothing more than an event. Well, there's events that happen that don't get in a log.
Yeah.
Hardware events are very important, especially if you get to edge
Edge.
computing, right? Et cetera. So keep in mind, events are part of that as well. So we'll touch on many of these things, but just to give you a kind of an outline. What drives these customers from a top level, the C-level execs coming down, SLOs, people think service level objectives, if you don't know what SLOs are. 99.9% availability is an SLO, for example, right? Latency, less than 2-second response time could be making up SLOs, right? But that's what they care about, driving to those, right? Cost is another driver, big driver. We're seeing that big time in the cloud. You probably read about it, where a lot of people have now realized, oh, public cloud is a lot more expensive. We need to cut back. And a lot of people are doing analysis on how to understand how to best utilize and drive their costs. Last but not least, nowhere near least, security. Security drives everything they're doing. In fact, I have a link here, but there was a study that came out just about a week ago at most. Red Hat did with a lot of about 600-ish DevOps users. And it's interesting. Close to 2/3 of the Kubernetes projects have either been delayed or put on stop. Right? Because security issues was number one. Another one, and Joydeep wants to talk about this, and we'll talk about it more as we go. Misconfiguration was another. And what drives to that is the lack, and we were talking about this earlier, the lack of expertise, knowledge, right? And in fact, that's kind of what this topic is talking about. These customers have been moving quickly from, we went hardware, we went to VMs, and then we quickly moved to containers. I'll go to hybrid cloud where some is in public, some is on-prem. All of a sudden, we're going to do Kubernetes. Wait a minute. All of these drive unique challenges in security. They drive unique challenges in how I monitor, what the information means to me, or what, put it this way, let me put it this, data is, and we talked about this earlier, they're collecting a whole lot of data, raw logs, raw metrics, et cetera. To us, that's not very useful. You got to turn the data into information, right? And they struggle with that because they don't even know these technologies. They're just figuring out still how to collect the data, right?
You reminded me, Randy, one of our big customers, big name, we all know, being recorded, so I'm not mentioning the name. They have transitioned to use OpenShift 4. And why I say the word, OpenShift 3 and OpenShift 4 is very different. It has matured much more. It requires different mindset altogether. And one of our field consultants said that these guys are more like the days of sysadmin. They are more towards that. They don't know about GitOps and things like that, all the modern practices we need to use to manage configuration. They are not aware about those things. So it's a huge learning curve, even for our customers. And they are all over the place, So when you propose something from a research perspective, be very aware of what is the level of the customer.
Yeah.
Or what is the sweet spot you guys want to target? Yeah.
So does Red Hat ever advise against moving towards these technologies like Kubernetes?
No, we are absolutely. We are big on, shutting down our screen from time to time. No, we
I don't know
don't.
what to do.
We don't.
Well, don't forget, we're like any other business. We got a sales engine driving. So, if you can make the sale,
And,
Go
and
for it.
Kubernetes is being adopted widely. In fact, back to the industry stuff that Randy was talking about. I've worked initially in process control space, and I see all the things, not all, what I see. All the things that were proprietary in process control, they are actually trying to move into Kubernetes these days. So that it can be uniform and all the proprietary protocols, etc., are getting broken. That obviously has its advantages.
Yep.
And it's being driven from the edge perspective as well.
well, and you mentioned earlier, question around buzzwords. And let's not kid ourselves. These customers hear some of these buzzwords. They hear that, oh, the industry's moving this way.
They
We
have to
need
go
to
there.
move that way so we can be competitive.
Yep.
In fact, the telco discussion and one of their lead architects has been driving Kubernetes because he sees, and GitOps, the combination, and he sees the value of desired state management that Kube gives you. They never really thought through a lot of the underlying challenges with that, but it's like, this is where we need to
This is
be.
where we need to.
Now, he's up
That's-
here looking at the big animal picture, fine, and he's pushing hard. But there are people, with their feet on the floor, trying to figure this all out and manage it and really, and it's not easy. It's not easy for them. And this tends to move faster than they're able to really become expertise on it.
Yeah, and back to the other question you asked, DevOps SRE, right? All of these, by the way, to operate efficiently, you require process changes. You require human beings to behave differently.
Yep.
That's the hardest part.
Yeah.
That's the hardest
Yeah,
part.
a mindset shift, culture shift, very, very hard. That takes 2-3 years minimum, right?
Yeah, but to go to your point, if you're talking to the C-level guy, infrastructure, and also probably application. I know for a fact from outside software, from customer perspective, cost, security, that's in everybody's mind. SLOs are these days actually, because that's what you get measured on.
Well, in fact, the hybrid cloud game of challenge is, okay, how I monitor, how I collect this data from Google is quite different than from Amazon. And I could also say it's quite different than if I'm running a cluster using EC2 versus I'm using AKE or EKS. We'll get Azure in there with AKS as well, but that all challenged, and the whole security of how do I collect that data? We were talking about the regionality aspect, right? And then just now, everybody's back to work. A lot of companies are looking to move the edge, right? Big customer retailers that you're working with,
Yeah.
they want to put a cluster in every physical store, which is what, about 8,000-ish, give or take, if I remember correctly, right? And what gives great reliability, if the back end connection goes offline, they can run their full business right there, right? Good idea. But now how do I manage all that and keep that going? And edge, and we start getting into, it was interesting, we had a discussion, why did edge come about? Well, because the volume of data that you're collecting is too much to bring back. So let's push the computational analytical, capabilities towards the edge where the data is and do that analysis, right? So it's all designed for, distributed computing paradigms, what it really is, pushing that out. Why? So that you're closer to where the source of the data is. But then you still have these monitoring people coming in and say, well, no, you got to bring all that data back centrally, all the logs, all the metrics and everything. Well, wait a minute, why couldn't we bring the business data back if we,
Yeah.
And these things are looking at, we're talking the bandwidth. When we were talking some of the cells, you're talking 5 megabits per second max is what they had.
Very, very constrained.
And guess what? That's shared with the business data. So the last thing you want to do is be on a cell call and all of a sudden it starts breaking up. Why? Because, somebody's collecting logs right now, this doesn't work very well.
That's exactly concretely what happened.
Yeah.
So, the stuff that again, I'm totally not an expert, Leslie knows so much more, but there's a lot of stuff that you hear about from things like was it Dapper, these end-to-end
Dapper.
sort of telemetry kinds of techniques.
Yep.
That are application level telemetry.
Yes.
Yeah,
And then, I think that what you're talking about is all about telemetry at the infrastructure level. And they seem to be, what bothers me is there seems to be a total disconnect
There-
between these.
in a
things.
lot of places
Is it-
there
so I
are,
just want to confirm, are you talking about purely telemetry at the infrastructure level rather than the business application level? And are they really as disconnected as it appears to be?
simple answer is yes, they are disconnected as it appears to be. But I'll give you an example, like on the collection. They were saying, okay, now apps can write, there's a standard Kubernetes login, it goes to the same, /var//. Why can't you forward their logs from an infrastructure? Yeah, we can, right? So they're looking for infrastructure services, because we've done this before, if the app writes to like Prometheus or provides a scrape point for Prometheus to scrape. Yeah, you can get all of their
But
metrics
it's
as
really-
well,
But I mean,
right?
the key is, okay, can we get, like, that, I love that statistical sort of sampling
Mhm.
at the application level that
Yeah.
you've done there.
Yeah.
And correlating that to actually find out what the heck happened to the infrastructure because.
So
of
we-
telemetry.
Sorry, go ahead.
As I said, a lot of it has to do with organizations. There are people in place that manage the infrastructure. Totally different organization than the app owners, right?
Yeah, they're totally different. So, I mean, on one level, the tools and the techniques that we use for infrastructure, logs, traces, back to your Dapper, metrics, events, analytics, they are applicable if we solve infrastructure problems. They're also applicable if we solve application problems, right? And as Randy said, infrastructure people and application people in lots of organizations, or most of the big ones we talk to, they are totally separate. They're totally separate, if you're an infrastructure guy and let's say you're creating a rocket science container app which is supposed to run, and you suspect that there is something happening with the cluster, you have to go to the cluster guy and ask him or her, the dude, can you show me what's happening? Because you don't have access to that. Right? That's just the way it is.
Actually even worse than that, because the stuff you put up there,
Mhm.
SLOs, right, that
Yep.
drives the people who are running the infrastructure. And that is not in their SLOs, right? How well the application is doing is not something they're measured on.
No.
Right, that's
Yeah.
the perfect,
Yeah.
I love how you point is that, like, that some of the stuff
There
that
is
we talked about before is it was being cognizant of the application SLO in order to impact what the infrastructure is doing,
Yeah.
and we have no visibility into it. So I guess what I was asking you was, you're validating that this is disconnected, and is it where you see the right future being?
It is
or-
intentionally disconnected. Okay, let's put it that way. I mean, we face it from our customers that the cluster admins do not want the application
No,
developers.
I
I would
understand that.
say-
What I'm asking though is, what I think Kai's saying is, if you could express the SLO of the application, or the metrics or the
Right.
characteristics, or if they could put in appropriate interfaces, then that could be part of the infrastructure team's responsibility.
I mean, you're spot on. I'm a firm believer. I don't know how you can manage infrastructure if you don't know what it's serving as the app type, right? I mean, some apps we all know are very CPU intensive. Others aren't. So if I'm looking at something, oh, this thing's running 90% CPU, that's a good thing, for
Yeah.
this app. For this workload, it may not be. We got a problem, right? So if you don't have a clue of the type, you're there in support of the business app, right? Nobody buys infrastructure for infrastructure's sake. So if you don't have that knowledge, I think it's very problematic. So you're spot on. The reason we're raising this is opportunity, right? That you talked about, right? I'll give you an example, like one of the first customers you talked to, first thing the infrastructure guys want to do is goes back to the cost. My apps are coming in, they're telling me, in Kubernetes, you have the concept of requests and limits, telling them how much CPU, memory, et cetera. They're coming in, their requests, you add them all up, they need X amount of CPU, X amount of memory. Next one needs X CPU, X memory, et cetera. Add them all up, it's a huge cluster. And we're seeing they're all running about 10% of that. Well, what do? They all
Wasted.
buffer, why not? They don't care, it's no cost to them. But it drives up the cost drastically, right? Because when you quickly add up all that buffer that each took, they're not doing a general across the board buffer, their costs are out of hand. So the first thing infrastructure is trying to do, tell me how much each app is doing, how much it's costing me, because I want to go back to them and reduce their usage on us. That's a different mindset than I'm here to support the apps, right?
Yeah. This is a common thing, right? But however, just break down, Heidi, that you said, between infrastructure and application. In Red Hat managed services, we are trying to do it a different way, Randy.
Yep.
Which is, the high level SLOs focus really from what the customer sees. So it is focusing on what the application, whatever you're serving. That requires immense, there is technicality, but more than that, there's immense process, buy-in that's required. It's not so easy.
Yeah.
It's not easy. It has to, you have to go through different organizations, different managers and things like that, and get a buy-in from everybody. Yes.
So, if a company is on a public cloud, so I don't think they are doing asking quota from each app team and provisioning for the quota, because I think they will all use auto scaling groups or something like that, and they will have their app scale according to the load. Why would they provision extra infrastructure if they are on a public cloud? Is this only for the people who are using?
No, public cloud is same. Because if they set up the request sizing, you don't, with KubeWorks, you won't even get this scheduled if there isn't enough resources to address what you've requested. That's at a pod level, right?
Yeah.
Now, you can also have namespace level quotas, et cetera. And what do you do? Oh, I need 20, whatever 20 means. I'm going to bump it up to 35 just to be safe, right? So now I need 35, right? And again, it works. Nobody's saying it doesn't work, but they're analyzing this and saying we're over provisioned. We're paying too much to the public cloud for what we're using, because in the real world, we're seeing instead of that 20 and they ask for 35, we're seeing it use 10. That could be gig of memory or CPU, whatever. But I'm just giving you a kind of a ratio. So that's really what's happening. It's the same whether it's on-prem or in public cloud. It's the same thing. They're not using as much.
No, and let me tie back one thing. Randy mentioned about born in the cloud customers. What you said is for born in the cloud customers. For the enterprise customers, no. I am the cluster admin. You want to come to me, you have to come to me and ask and say, hey, Joydeep, I need a namespace where I will run, I need a namespace pool where I will run my application.
Born in the cloud companies have a better much different mindset.
Much different.
And they have more of an infrastructure app view. They were built for the app.
Yeah.
Infrastructure comes along.
Yeah.
They have that app mentality. The larger customers are talking about with a central IT org that does infrastructure has an old school mentality of I'm still purchasing servers the old days and bringing them in as physical. That's the mindset.
So you will ask, I won't, you will, when you say you want to create an application called foo, I will create a namespace called foo, and you will tell me, oh, this is my request and limit. Okay. I will see whether that can be provisioned. That's it. Or in some cases, I might even set a quota at the namespace level. That's it.
Yep.
Auto scaling, at least the larger names that we talk with, I don't think they auto scale that much, actually.
Well,
so born in cloud again works totally different.
And in reality, the reason they don't, a lot of these customers, believe it or not, are still bringing their old implementation. Oh, we containerized it, brought it over, and we haven't really refactored the code
to
in
do all
such that it can horizontally scale in a seamless manner, right?
What I have seen is if you are born in cloud, and your business was successful, then you are in cloud and your bill is high. Then people think that okay, I'll go back to buying my own infrastructure. But I think the main promise of the cloud is the flexibility that you are using what you are paying for what you are using. So that
in theory,
and that is where this increases astronomically, because people can do anything.
but you're not really paying for what you're using because you can ask for a base, give me X. And that's the problem, and he'll scale out, right? But the base is way too high.
Way too high.
Right? So for example, I'll spit up a 6-node cluster and it's sitting back right now doing nothing, right? And I'm paying for that. So that's what it's the base that they spawn, and you're spot on. That ability to do what the public cloud gives them is great, especially in the development side of things, right?
You have a question, sir?
I want to go back to this thing about the communication of the interaction to the application level folks.
I think a common set of conversations that occur between people, like, there's nothing in infrastructure or the monitoring of the logs that say ties them together. I can definitely imagine cases where like, the SREs are like, your nodes are taking way too many resources.
Yes.
to, like, reduce them.
Yes.
Or the application developers might be like, hey, look, I need a lot more IO for logs.
That's exactly what it
Or,
is.
so the Peter thing, we just talked about how like, even the same multiple containers running the same node, they all use STD, they all type the standard average.
Yep,
10
yep,
errors,
exactly.
log, like Kubernetes.
Right.
And then say containers on the same node containing each other.
Yes.
Mhm.
For log out.
Yep, yep.
So it seems like there must be a common set of conversation. So I'm curious.
Yeah, and there is, I mean, because you mentioned this earlier, let's say an app run, if I'm gonna use a generic one-to-one, a namespace is an app, it's not always one-to-one, but let's go, they go and they get assigned a namespace. And we also, customers say, I want a dedicated cluster per app, or I want to share. Some have affinity to certain nodes, like I have a 10 node
I need a
cluster,
GPU.
you're gonna get 3 nodes, you're gonna get 3 nodes, yeah, or you need a specialized node GPU. So they have those conversations, right, of how we're going to deploy you, right? And we can make sure that you run in this set of nodes or on this cluster only or whatever, right? But that's about as far as I've seen it get, right? Once it's running, they really don't have a feel for what's happening inside those containers. Sure, you can look at contention for infrastructure resources like standard .NET, but they don't know what the one thing is writing is the order entry system and the other
Yeah,
thing
yeah.
writing is whatever, right?
The infrastructure guys will not talk to the application guys about the tapper. They won't talk.
Yeah.
That's application. But they do talk about contention and things like that, right? And that is very real. That really happens. And as we'll talk about later, in Kubernetes, it makes it even more fascinating. You don't even know that something has changed under the covers.
Yep.
That influences things, right?
But you're spot on is, so if we can come up with ways to be able to correlate application specific information with infrastructure, vice versa, it's very, very powerful.
It's very, very powerful. I mean, that was one of the things, remember, Randy, we were doing in IBM where we wanted from the network to infrastructure to application all the way up.
Yep.
They were trying to build a stack.
Yep.
But again, going back to your question, if we were, my favorite example is if you're like Instagram, when they first started. 13 developers, out of which probably very few were functional. I mean, there was a handful. If it's that small team, everybody knows everything. That's the goal. If everybody knows everything, then life is bliss. You won't have these silos. In a big organization, that's real. People are, these folks are supposed to do this, these folks are supposed to do this. You cannot suddenly come and tell, hey, everybody does the same thing. And oh, by the way, I can do it with 50% less people. You won't do that.
So let's move.
Data is increasing rapidly.
We talked about that, getting to the edge, amount of data being collected. How do we deal with that better, right? In fact, one of the things Joydeep and I started with, this concept of dynamic monitoring. And it goes back to some of those smaller single node memberships, right? Why am I collecting all of these metrics? Last thing, how do I collect pod level metrics? I don't care, right? To some degree. But let's say if your memory or CPU utilization is starting to go beyond the historical norm, well, okay, which pod is causing, what pod per NS is causing the problems, you need to know. But why am I collecting data every 1 minute, 2 minutes, whatever? I'm just collecting a whole bunch of noise and I don't have the bandwidth. So what can we do smarter at the edge? You want to get the data, but you also don't want to wait till a problem occurs and then you get the data. That doesn't do you a whole lot of good either, right? So you almost have to be, and we're going to talk about this a little bit when we get down in front, you almost have to have the proactive knowledge that says, I understand what is starting to go awry with my system. Let me collect a little more information. So either one, self-heal, I think we talked about autonomic a while back, I'll use that term, or two, at least provide enough information to help with root cause analysis. Back to your SLOs, if I do have a problem that impacts my service, I need to get that back online as soon as possible to avoid breaching the service level objective, right? So how do I quickly get that back online?
Right, and the other point that you mentioned, Randy, the split, I should say, in edge, when I'm analyzing images, trying to see if soldering is wrong, right? I am actually running that image recognition at the factory floor at the edge. When it comes to observability, monitoring, we are really not there yet in terms of thinking. We tend to say, as we said, send all the data back.
Right. Right.
And the dynamic stuff is trying to move towards that, right? So let me do some intelligent stuff here so that I can only send what is, so I can be a little smarter about what I send back.
Well, I'll give you an example. We talked about that telco example. Well, they start, okay, we need logs. We got to forward the logs, right? And one of their use cases of logs is around audit, right? And security breaching. Kubernetes audit logs, if you've ever looked at them, very, very, very noisy, right? So they start like, whoa, this is way too much volume. How do we, get that down? And they're just trial and error right now, trying to make sure they don't miss important log entries and collect that data back, right? There's no analytics helping them to determine, and we all know how logs are, the writer kind of defines what's put in there, right? And so you can't really collect all the logs. They need to, from a security perspective, make sure there's nothing being breached, but that's a real challenge, right? How do we get that data back and what data?
There's no security around the log itself. And attacker could just edit the logs and then you never know.
I mean,
That's not true. If you're shipping the logs off somewhere else, the attacker can edit the logs on a local machine that they've compromised.
Right.
But if you are shipping them off somewhere else, you can have security and you can have cryptographic hashes and what you've received and all those things.
Yeah. So the raw log, the source. Well,
Right, but if you're doing the analysis stuff, you're probably collecting them centrally.
And
so
then
Yes,
you're sending them somewhere else.
and that's the challenge. They're
You've got a
taking,
copy that's not been modified.
Right.
Whether it has useful information on it is a different question.
Right.
But you can generally trust that it has not been modified.
Let's talk about that.
but you bring up a great point. If this machine's already been compromised and the logs themselves have been compromised and have, data in there that is not trusted, yes, you have a problem, right? But you're hoping if you collect the logs right, you can detect that point when it went from trusted to non-trusted or when it was breached, right? So that's a challenge.
Another one was,
Yep.
the logging and tracing infrastructure. So what kind of, in practice, what kind of infrastructure do you see? So there are Dapper or Zipkin or Jaeger, and then for logging, people use Splunk and agents to ship back the log. So what kind of things do you see generally in practice? And how much are they useful in debugging or doing things like that?
So we'll talk about this a little later. But logs, they tend to capture and store Splunk, Elastic, whatever. Yep. A lot of that is for debugging, but the app owners, which goes back to the app, the collecting them on the app owners find it useful. They know the logs, right? If there's an app problem. The majority, though, are looking for auditing because many of these large customers we're talking to, financial, insurance companies, things like that, they need to have audit logs collected because they're in regulated industries and things, right? So that's one aspect of it. And others are doing things like you could talk about Splunk, for example, setting up alerts, alerting rules based on log, and some are doing that as well, right? But
And if you take into account, I don't know if this is a term you folks about open telemetry. That's a project for helping make collection more sensible, more sanitized and stuff like that. They say that it's all over the place. So that's why they are vendor made. Technology is all over the place. People are using all sorts of stuff. By the way, collecting logs, collecting metrics and traces is not something new. 20 years ago, in IBM, when WebSphere was the world, we were collecting metrics, not only we, there were all our competition. We were collecting metrics and traces, and you click on a metric, drill down, it shows you the trace. We had that. But that was on one WebSphere, limited distributed system. Now it's, of course, much more complicated. So in a way,
Yeah. And I do want to go back to this one real quick is another challenge that's facing them is if you think about it, and Lars kind of talked about this, I can take the data off and then analyze it, filter it, analyze it, reduce it, et cetera. I don't have the bandwidth unless I'm pulling it locally, right? Like within factory forward. I don't have the bandwidth to send it back locally, centrally and do that. So, but also the challenge is a lot of the analysis on the device itself. I don't have the CPU cycles. Those are very small, finite devices that are usually running as tight as they can on resources, right? On the CPU memory. So that's one of the challenges we have, and you got to think about it. So how do we, and that's where we were thinking of, we did and actually implemented some of the dynamic data collection, right? Because actually can reduce the amount of CPU, you're collecting less data scraping, versus collect it all and filter, which is kind of, you're using probably the most amount of CPU, right? So how do we do that, and how do we do it in an intelligent way? We did it in a way where we knew what all of the information around relationships, you know, a priori, so we could put some of these rules in. And I wish I could monitor what's going on with this
you know,
adapter.
The catch there is that platform. That means Red Hat operating software should use as little CPU as possible so that everything is left to the application that runs. That's the goal. And it's really, you know, grinding us down to dirt to make sure we don't use, I mean, we use as minimum as possible.
So,
What question before? What
I
time?
just want to let you know, so it's 1 o'clock now.
1:30.
I
I mean, we go till
right,
1:30.
yes, some people,
Just in case people have other commitments.
Have to go, yeah. Right.
The garbage is outside the door.
We can move on to,
So you have to.
okay, yeah, let's,
Don't think that people are walking off because it's getting.
I have actually somebody, no,
Can I ask one more question, please? since
You just did.
Austin, I know people here are interested.
Yeah.
Yeah, one more. So there's several people who are working on carbon footprint as a measurable thing that could drive operations. And
Yep.
I know you guys have run into it too. Is it real, or is it something that people aspire to?
it's at the sea level, it's very real. I think when it gets down to the people day to day doing the operational, it hasn't hit them. And again, that's a general statement, you know, general statements are, I can find an exception to every rule, right?
Yeah, but I'll make a statement, Randy. When when we were talking about upstairs, it struck me that Google data center reduced its cooling costs probably by a huge amount, like 25 to 40. And the guy who did it, one of the spearheads, had nothing to do with machine learning and things like that. But that guy started a project that used reinforcement learning to reduce the data center cooling costs. And he was solely driven by that. Okay, that indirectly, that of course directly helped in carbon footprint, but I don't know if the focus was carbon footprint then. It was pure money.
Right. So one thing I want to spend a little time on, and to me, this is very important. Most monitoring we do today is very reactive, right? We detect the problem, we react to that, fix a problem. I don't care if that means something crashed or if that means security breach or whatever. We have a lot of rules and they could be manually defined, automated defined. But anytime there's a problem, how do? We want to reduce the amount of time it takes to restore the service, right? Focus on, you know, root cause analysis and improve MTTR. We have something like that. Well, we've been
Causality is a
doing,
bad word. So
Yeah.
causality is generally a bad word in,
Yeah. And you're not going to get away from that. Things break,
of course.
physically break, whatever. I've seen where literally cars run into a pole that brings the cell tower down. I mean, things break, right? But you want to minimize. You know, today, everybody's running 100% react. You really want to, and Red Hat's starting to do this, we're talking about another. How do we get them to proactive management, right? And we'll talk about this a little bit later in the chart around having the knowledge of causality and things. But you really want to get these customers to a model where they're doing proactive management. And that can vary greatly from, like Joydeep has his favorite pet peeve is people make configuration changes and it has adverse effects. They know they're changing X from 10 to 20. They have no idea that affects some other thing down here, right? And so their change, it's not, you know, intentionally to be problematic. It's just ignorance, right? Downstream. It causes a problem, they get the alarm, they go fix it, right? That's reactive. It has a negative impact on their business. Proactive, if I can understand that and avoid making those changes that have a downstream impact, I never take a hit, right? And so that's where we need to give them knowledge to help them be more proactive in their management. They can start to, people did this all the time. A simple example, trend analysis. I just did a linear regression. Oh, I'm going to be out of CPU if everything just goes that way. That's proactive. And they ordered more CPU before they hit the end of that curve. That's old, simplest case, right? But how do we do that in these new modern environments, especially dynamic, scaling, et cetera? Is that a question?
Yeah, just wanted to see, transition from reactive to proactive management, to give a management example. But in terms of the monitoring data you actually collect, what will be the difference? Like,
So we'll talk about it. Let's.
Yeah.
We'll talk
Try to move on quick. And then Joydeep brought this up too. You're also seeing where these customers are starting to change their mindset, where instead of just monitoring all these back knobs, like, oh, what's CPU, what's memory, versus having no knowledge of what's running, they're moving to where let's monitor and think about the end user experience, right? And
So this is, good.
I was just saying, a good example, a couple of years ago, in fact, the IBM CEO mentioned this in one of his talks. The Weather Channel data center during one of the hurricanes, because there was so much activity on it. The whole back end was falling apart left, right, and center just because of the volume hitting them. But it never went down and never impacted the end user experience because it was recovering the back end. Because do we have problems? Sure, we had tons of problems, but we didn't affect the user experience, right?
Yeah, didn't impact. And so this goes into, obviously, Brandy and I were just talking about it. We started down this journey probably on digital experience monitoring. The first seeds were probably planted as early as late 1990s, but it takes much more time for it to mature. And obviously the industry moving more into SaaS makes it much more easier.
Yeah.
So they are monitoring, okay, are people clicking 3 things and then bailing out from this page? Are people really completing the transaction and things like that? At one point, trust me, this was called clickstream warehouse.
Yeah.
And now it's totally moved. We use totally different technologies to do that, which there's a picture of that in the next slide. But yeah, industry is very much more focused. Everybody, I think most of even the customers whom we talk to, they are focused on digital experience.
One thing, last thing I mentioned is, while they're changing all these technologies and kind of trying to change their mindset, they spent a whole lot of time.
This is real.
This is real. We did a survey and on an average, you know what averages do, but on an average, these enterprises have about 7 different monitoring tools. It comes across because Shadow IT, this app team creates one, mergers and acquisitions. I bought a company, they're using X, we're using Y. And this is real. I mean, to consolidate, bring them together, or even be able to bring the data together and correlate takes a lot of resources. But guess what? That takes you away from doing some of this other stuff. They have finite staff. So that's a real challenge right there. And things like open telemetry hopefully will help some of that collecting, normalize it. So let's not kid ourselves. They haven't even defined a spec of what a metric will look like yet, the protocol. So
They have started defining.
well, they still, but they
They have
haven't
started,
defined.
yeah.
That's my
Yeah,
point,
they're trying to
right?
move, yeah.
Okay, so let's move on. This is kind of a picture of some of the stuff Red Hat's doing. Some interesting, some not. And then I want to quickly get to the next conversation because it might generate. So, I think the key you'll see that we're seeing within Red Hat, this is on the SaaS side, and most of the customers we're seeing, they're collecting logs, they're collecting metrics within Red Hat. We're doing config file collection.
And that's the user navigation is the digital experience.
Yeah. And they're all going up into different domains, so they're not correlating the data. And as you'll notice, trace data is not on there. Most customers we talk to are not collecting trace data. Just way too much. It's not good enough for dealing with exemplars that you need for the good trace data collection. And it's really not giving them the value they need. They'll do it in development, but in production, way too much data or operations doesn't get anything out of it. This one's interesting. The config talks about logs and security rules. I think there was some of the questions around looking at exactly what they're doing with alerts. Configuration, and it includes some metrics too. We have rules and we'll learn on them. But we also have the concept of recommendations. And we're analyzing the config and understanding, oh, with the way you have this set up, you're not going to be able to do an upgrade from this level to this level with this config set that way.
It's very, very helpful.
Right. It sounds simple, but that's very helpful, like you said. And so that's proactive. We're telling them, look, you already have this config that's going to prevent you. If you try it, you're gonna have a problem, right? And a lot of this is done through, we send all the data, doing data analysis and analytics against the data and coming up with some of these rules that will either give them give an alert or a recommendation, right? So you can start to say, yeah, reactive is not going away, but we're trying to do more and more proactive,
Yeah.
right? And it's very, very beneficial because it's saving these customers. Oh, okay, I got something set up wrong. And they're telling you what it's going to cause a problem with. Well, might cause other problems, but they're giving you definitely some guidance. Now, granted, it's up to the customer to decide if he or she wants to take that recommendation or not. But again, huge
Yeah,
help.
they're huge. And some of these recommendations are dead simple.
Oh,
You have a wrong configuration. There is no rocket science. There is no machine learning about it. Just plain simple, but very useful.
Oh, here's a, go ahead.
No, and additionally, the other thing that's happening in Red Hat is looking at the data across all the customers, okay? High level data, but across all the customers. So Red Hat can generalize that very well. Learning from, okay, I am, let's say I'm just doing a rollout and it's been rolled out to 15 customers and I can already see problems happening. Quickly react and, put this thing to the other 500 customers that will come online. Please don't do it.
Well, we have
Something like that.
We have some internal knowledge. I mean, we produce OpenShift.
Yeah.
We have some knowledge from our development teams that says, oh, you do this, that is bad, right? Well, why don't we bring that knowledge forward to our customers instead of keeping it in the developer's head? We always thought about this in WebSphere recognizing. We know all these things, but we never give it to our customers or at least give it to the analysis of the data and make their life better.
Look at the PDF documentations that are produced. Tons and tons of PDF documentation. They are all causal. We have written from ages that this is, you just look at it and say, okay, this is pure causality explained in the document. It's not going to the analysis of the data. Why?
Is that configuration is box right now? Like, what is it currently? Is it like a software? Is it like a PDF?
It's a piece of software. So in the OpenShift clusters, if you install, you will see a thing called insights operator that runs, that periodically collects data, collects some logs, alerts, lots of configurations, and it also depends on what's happening with the cluster, sends it up to cloud.red hat, where they run the analysis. In some cases, they also combine with metrics, as Randy said.
Yep. And you brought up a really good point. I mean, geez, heck, we just read half of these docs, build up some knowledge in the machine learning and help customer greatly, right? That's how a lot of these models are built. Just bringing all this data in.
The example, flip on anyway. The example that we talked about, Randy, I think it was in Watson. One of the examples was given that it will read a washing machine instruction on how to repair washing machines and convert that into a nice causal graph or at least a topology. We could do the same thing here in the monitoring space. Why don't we do it? Who is stopping us from doing it? Just because causality is hard? Just because there is no treatment and control? Give me a break.
Well,
That's not
yeah. Well, and what we're going to kind of, because people are still doing a lot of the same things they did in the past, because the technology is changing on them, the shift of, this and that. They don't really have time to advance. So if research and implementation, like an open source could help them advance, that would be great. Most of them are still looking at raw data. They're not bringing it and correlating it and making informational knowledge.
And I guess the other thing that happens, Randy, is this experience, the things that we have learned with the technology. When the underlying technology changes, almost, fresh set of people, fresh set of learning, a lot of the earlier lessons are got lost.
Now, you will see some of this, and I'll let you drive it, but before we get there, and let me just finish my comment and go to your question. You will see some of this happening in some of the tools, right? When I talk about the tools like, a Dynatrace and then Relic, a Datadog, those types of tools, right? And you're starting to see things go blank again. You're starting to see, like, for example, Datadog talked about how they're catching and detecting causality and helping root cause, but they're not really helping you go to, proactive. So we're trying to go to the next step, as Joydeep said, this has been around for a while. We've been talking about this for a while, it's starting to mature. But again, are we looking to help one or two tool vendors? Are we looking to help? Because they're very expensive, and most customers have those tools, but they have them on very specific business critical apps only. The rest are doing pretty much just generic monitoring. How do we help them get this value across everything? You got a question, right?
Yes, can you go back to the previous slide?
I hope that one.
So I think here we have assumed that everyone will be interested in monitoring is going to connect to very percent in their data for analysis. But what if I am in a situation where I want to run my workload in a disconnected environment? What do you recommend for monitoring in that situation? We are talking about New Relic and Datadog and new companies like that. They wouldn't say anything when it comes to optimize, but there are options that people connect to cloud and will get information from. So there's a section of users, so not connected to the internet because of various applications.
Oh, yeah, Edge, for example, is not. None of those edge devices are connected to the internet. I couldn't do that.
Thanks. Thanks.
You're spot on. And don't get me wrong, those tools are very good. In fact, I've done deep analysis on many of them. And we'll go into, I can't share some of the other things, I'll get shot. But there's another challenge. When they're SaaS implementations, even if I do some of my data cloud, let's say tomorrow I want to go from New Relic to Datadog. Guess what? I've lost all that history. I don't bring that data forward with me, right? So it's gone. So there's that other challenge. So you're spot.
But how effective is this? How much are you getting customers to buy in the shipping review with Red Hat?
This, I'll be honest with you, this is in its infancy, okay? If we can start to get better at this, it's back to you don't talk to the customer about monitoring, you talk to them about the value you're giving them on preventing outages and things like that, right? We're not there yet, I'll be honest with you, but I see great promise in this approach, right? So that's why I wanted to call it to your attention, but how do we think about making this better for the customer, right? So that they're either one, trusting the data, and you're back spot on. And we have to make sure it's obfuscated and all that fun stuff, right? We have to make sure it's not crossing geographic boundaries and all that other fun stuff, right? We have a lot of challenges with that in security, right? And so you're 100% right, but can we also then provide it where they can run it on-prem if they want? Why not? In fact, we've talked about within Red Hat, can we, once we get this more mature, can we deliver it as an on-prem version for those customers that are connected? Because we do understand a lot of our customers are that way, right? And they're valid concerns, right? Anyways, let's get through this.
Yeah, going back here. So the next 3 slides are actually the same thing. If we were whiteboarding, we would, whiteboard one after the other. Typical scenario. You get an alert. And so this is about a mythical, let's say, traffic is flowing in a freeway. And all of a sudden there is a blockage. Things start to slow down. Not a blockage, things start to slow down, come to a crawl. So, you're getting an alert because your traffic flow has gone outside the norm. So you get an alert, go to a dashboard, you check the traffic flow is going outside the norm, but traffic volume is okay. So what happened? Why did this happen? And what we normally tend to look at, if you talk about the monitoring domain, we tend to look at a lot of signals to find out, what's the correlation and stuff like that, right? The root question is, what's changed? This is the major thing that we all psychologically do, but we never pivot on that. My experience working, on a customer company, all of you know the name. We were moving some monolithic app to microservices, and anytime things broke, the VP from next door came rushing and said, "Joydeep, what's changed?" It took me, I knew I was just checking that. It took me a few days to realize we actually should think differently and just focus on what's changed. Back in the day, when we were running WebSphere, a big bank, again, we know the name. They said that they used to run a Python or a Python script every night. If in WebSphere, the configuration was stored in XML files. They used to run a script every night to find out what changes have happened to the configuration. So when we started to talk about our tool, which showed metrics and traces, they said, your tool is good, but this is the key thing. This tells us what's changed so that we can go and look at it. Absolutely. What's changed? Newton's second law of motion. If things don't change, things just work, unless your software itself is screwed up, right? But so if something has to change, why don't we focus on what's changed? Can we abstract that, right?
And to add to that, with this move to GitOps actually helps us. Before somebody would come in and just type it on and boom. Now you actually have a PR that gets pushed and you can have an approval process. So
it's much more easier. So let's so so here you get an alert. From this, you cannot make out anything. Now you look at the volume, you're still scratching your head, and maybe this shows only flow and volume. Think about many other metrics. You're still scratching your head. Why did I get this? This is the event that Randy was talking about, which we just ignore. Once we have moved to Kubernetes domain, this is amazing. I mean, there are some pillars in Kubernetes domain where we just don't talk about events at all. And if we go back to systems of previous years, event was very important. And there are certain things which are really events. What really happened here was that a car broke down. And what's even interesting is this car could have broken down. Here we show that traffic is coming. The flow is reducing. But imagine this happened on a Friday night. The flow would continue same way, unimpeded, till a later time. So the event could have happened much earlier, but this is what changed. This is what caused it, right? So we are talking about, of course, flow and volume is time series data. We are talking about events which are discrete things that happen in time, and we will tie on to some of the other questions. And probably this is the seed of having some topology, some real DAGs, topology being from maybe you learn something from Dapper or Zipkin or something like that, and some real DAGs here to do graphical analysis, right? To do causal analysis. We often miss this. And anytime things go wrong, shared experience, something has to change. What can change? Either the change can be in configuration, right? Configuration could be, somebody has gone and maybe reduced the, DB connection pool size. Or maybe in Kubernetes world, as Randy mentioned, the DB has been moved to another node where it's throttled. Both can happen, so Kubernetes increase the complexity. Or maybe your load change, the load on the system change, right? Which is actually you're detecting a change because the metric level suddenly has changed, right? Or a new API is being used, which was not used. That's another change. And the most fundamental change is some dude checked in code. I remember in my control system classes, we were talking about, it was very interesting discussion. The Laplace transform, Fourier analysis, first order system, second order system, you give a step input and then the system settles down, all fantastic. At the end of the day, the professor told us, by the way, the basic thing that goes wrong is the fuse is blown. Keep that in mind. None of these things change. The basic thing is some fuse is blown somewhere which is causing the problem. Somebody has checked in code. If we were just to give that, somebody has checked in code or there is some change going on in the system, which might be relevant. And the trick here is what is relevant. You have an ocean of things that might change. Be smart and give the user what is relevant to them. That section. That can actually start from simple naive and it can go to rocket science. And there's a lot of learning there, but we can begin from very simple things. Give a change of code, give a change of configuration. And maybe, if you really know what metrics represent the load on the system, you can maybe detect level changes in the load and give it. Yeah.
So is this something that we can do right now with the observability tools? When I sit down and say, give me a graph of this next against GitOps deployment events.
We should be able to do it. Absolutely.
But we can't today easily.
No, we can't today easily because we are not thinking about this.
Could we? Yes. Can you take the tools off the shelf and do that today? No.
No, I mean, one of the principal limitations is in the infrastructure that we have. If you try to surface events, you wouldn't find out a way to surface events.
Now,
Events are not metrics, right?
now with that said, Coop tries to convert events to metrics and one of the things. So I have seen where people are monitoring their pipeline. And via a metric, they can see code had changed and bring that together and do something similar, but it's not near real-time events, date, et cetera.
And it is like, it is going in a very roundabout way to get an event. Writing 15 lines of code to transform an event to a metric so that we can see the reflection. That's very young.
Yeah.
That hurts at least our head. Why are we doing like
So I'm
that?
gonna follow up the question. So right now, I mean, we have tools for collecting metrics like communities. We have tools for collecting logs like last witness was and Loki. What do we have that deals with events that's out there right now?
We don't.
Okay.
That's one of the pet peeves with it on Coop. There's nothing, right? We've been actually working on some things that can capture Kubernetes events and publish them out to like a Kafka or whatever, normalized, or even publish them over to an Ansible that deals with events.
Well, my question wasn't even specific to Kubernetes, because I mean, this has been an
Yeah.
issue for 50 years, right? And we've had metrics gathering for that time.
Now,
We've
there-
had log
yeah.
gathering, but
But
we've never
like this,
been-
so in these.
There are
certain
some-
tools, they do it.
Yeah.
Yeah.
It's
There are some event management systems that'll do that. And they'll go all the way from informational events to critical events. Omnibus is one that's been around forever that'll do that. You can collect events. I mean, old days of S&MP trap collection and things could. So in fact, events was the first way we ever started
Yeah,
monitoring.
yeah.
Before we even had metrics, events were the first thing, right? And it's almost like we've gotten away from the event aspect of it.
There are no open source implementations. They are all,
Yeah.
That's the deal. Yeah.
You mentioned log collection
Yes.
and then the events and like.
So think about it this way.
Yeah, why isn't the log an event, a log with a certain priority or certain importance in the event?
So think about it this way. I mean, okay, structurally, they look much like logs, right? Something has happened in point of time. There are a couple of fundamental differences. Log is written by a developer. So if I remember correctly, Randy, when he coded, for every warning stuff, he did 3 exclamation marks. And for every error, I did X, so that he could jump out. So logs are filled up with developer idiosyncrasies. And anytime you try to normal and then you're using Klog, you're using Jlog, you're using Glog, it's all over the place, right? So standardizing logs is very, very hard. Events, on the other hand, Kubernetes events, if you look at Kubernetes documentation, Kubernetes will tell you, don't look at events because, there's events, there is no guarantee. Each controller emits its own sweet event. And it will also say that it cannot be stored in its CD for more than 24 hours. And if push comes to a shove, that is the first one that's kicked out, right? So Kubernetes right at the outset tells that don't look at events, which is kind of okay. And probably it's related to the maturity. When Google brought up Kubernetes, Google is sitting in that place, very, very mature customer.
Yeah.
Now, events, there's the other part of the event is you will usually have some kind of governance around events. So that is where, in fact, I would say if you're taking events for machine learning, I would say that you require less feature engineering because that's already cleaner data. And in complex business processes, right, where one thing calls another, the other thing calls another, how do they get the visibility of the thing? It's often events. And we are getting buy-in, Randy, as you said, from real life customers.
Well, and the other aspect, so yes, a log file is nothing more than a recording of events, right? That's a simple file. But the reality is, by the time you collect all that, take it offline, aggregate it, filter it, etc., there's a long latency there where you actually, an event, you want to process it near real time.
Near real time, right? And unless there is some kind of a huge storm happening, It should,
But,
it's
but
much more lesser.
let me just sort of be obnoxious here, it's not, I mean, but I mean, so when you're talking to a research community here, right? We can sort of do innovative things with the context of the information that's there. You're arguing for a fundamental new requirement that isn't in the tools. So it's not like we're the worst people to talk to because we can't introduce anything in any real world
Right, right.
environment, right? So we may agree with you, but we can't really.
But collecting events is, it won't be that hard. As Randy said, we are already doing something. There are some Kubernetes tools using which you collect events, and what we know, that is domain knowledge, is that instead of trying to figure out what not to look at, just start with what do we look at? Just
Well,
start with a minimal
And
list.
Joydeep talked about some of the reasons Kube is saying no. You can publish those events immediately to something like a Kafka that does have guaranteed delivery and things, right? So you can get past some of Kube saying, I'm not doing guaranteed delivery, right? That you can.
So you're saying that the events that we need are already there, they're
Yeah.
just not.
Yeah,
And some of the events you have to manufacture, like, for example, load change. Load change is a drastic load change is an event, which you could actually see. Let's assume that your traffic has increased. So traffic is a metric. You look at that metric line and see if there is a jump, create an event.
Yeah.
Which is being done in lots of streaming analytics anyway. I notice a sudden change, I
Or-
push.
yeah, and you can take an alert, and that is. a
You
form
can
of
take an
that.
alert, right, absolutely.
But what's actually more important than just these events, we want to get into this, is if you think about this, having this knowledge, what changed, it's great. It helps me go back and do root cause, improve my MTTR. Well, let's take it a step further. And why can't we use that causality knowledge to prevent these incidents, right?
Right.
Which is where I'm going. We used to do this analysis where we build up this causality graph and multivariate causality graph, right? And I kept saying, and then they tried to run data through it and see what, oh, got a problem here. But just that the knowledge is the value, not trying to monitor against that graph. Having that knowledge of the graph, now I can do some upfront modeling or analytics to say, if you make this change, your adverse effects is going to be ABC, right?
Right, so think about it, I mean, you are not doing a full-fledged causal discovery, okay? There is some domain knowledge, it has to be domain knowledge. We understand the systems that we are doing, don't tell me, you don't have any domain knowledge. You have to discover everything from the data, push it.
Domain knowledge. Yeah.
So, let's abstract that. System fails when there is a change in configuration, when there is some change in behavior pattern, or when there is a push of code. So this start building a causal DAG with this. Once you build up a causal DAG, that immediately helps in doing the MTTR. Now, if you learn with the data, then all of a sudden, can't we go back here and get to these kind of, counterfactual and these kind of analysis? That what happens if I change this? Can't we do those kind of things? Can't we take the next step forward?
Yeah, don't worry about building the causality graph, right? We could, how do we take that data and do it analytics
Right.
to prevent these changes? You're not going to prevent a break. I get that. But I guess Joyce pushing code, hey, I can analyze this.
You can analyze it, right? Change it.
Prior approving the PR. I want to make this config change. I can give people back. I
And
mean,
I think out of the box, you can probably catch 80% of the config changes without, with very minimal knowledge. Just know how to read the Kubernetes deployment, you can find out, what the config changes are. There would be some esoteric things which you have to understand the topology of the service. Let's say you don't understand, but hit the 80%.
Yeah. Well, and let's going back to ACM, I always thought ACM is a classic one. What we're really talking about, I think bring some of these data sources together and analyze. ACM was classic about that. They have application lifecycle management, right? I want to push an application or an update, an application out. And we collect all this information about the health of these clusters we're managing. And they do things by groups, by labels, right? But whatever, okay, push this update out. It's going to go to these 10 clusters. Well, what if this cluster is already missing its SLO? Why are you pushing something new there, right? The system should be smart enough. We know the SLO about the cluster. We know we're trying to push a graph, but we don't bring it together and say,
Yeah.
you sure you want to do this to that thing? It's already missing its SLO. Why you? Now, the update might be to fix the problem, please, but at least it's like, are you sure you want to delete the file? Yes, but we don't give them any of that, contextual knowledge or causality knowledge that we have. And that's huge. I mean, that's to me the open space. And you're starting to see, we talked about causality with root cause analysis. We want to take the next level. How can causality help with moving to a proactive management style? I mean, go back, I think it was about 2 years ago, Dario, the IBM director. Okay, just the last comment was pitching about a lot of their AI is focused on causality knowledge, right? Analysis. I mean, we have the ability to do some of this today. Back to Joydeep's statement of we have a priori knowledge. We could build a simple graph.
So
In
there
fact,
are,
Red Hat's doing some of that when I was telling you about the recommendation. We have a simple causality topology, right? So we're starting, that's why I said it's in its infancy, right? Got a long ways to go. Yep.
but that is a wide area. That's the, sorry?
We have like a pipeline.
No. Now, actually, Red Hat is doing causal analysis. One thing, the update of OpenShift. So you can, it's where actually Red Hat is using a causal graph to recommend, if you are here, don't go and update to this level or upgrade to this level. Red Hat is doing that minimally, but I think this in the monitoring space is wide open. And what we have been talking about is, don't look at the 600 metrics to find out what's going on.
Can't do that anymore.
You can't do that anymore. Abstract it to what's changed, configuration change and behavior change. Abstract it to that level and try to do it.
Oh, and think about, we talked about skills. That's one of they're moving so fast, people don't have these skills. So if we could create causality graph and tell them the change they're going to make, what impact it could have on them, or don't make this change, in fact, greatly, they don't know. It's ignorant, right? And they're not going, they don't have the time to improve their skills. In fact, part of that study talked about why some of these projects are on hold because of lack of skills and expertise. Well, wait a minute, let's use AI to help them, right? And using this causality graph and help them better manage these clusters, VMs, or whatever. Because we know some of this, don't we? Do I have to wait till it's perfect? No. Right.
Sounds like you're saying even something really is dead simple.
Yes.
Yep.
Take the place where you're managing your software changes, take those date stamps, make a custom dashboard that shows you what things went out today that changed.
Yeah,
right.
That would help if you could call that out.
Absolutely.
You get paged at 2 a.m. You have no idea Joydeep pushed something out at 11 p.m. Right? That caused that.
So there's lots of opportunities.
There's lots
Yeah.
of opportunity.
Yeah.
Try it.
And at that point, back to the question you asked earlier, I can bet on it that if you tell them. Okay, that's the end.
That's the end. Ta-da.
We are over that.
You're
You
going
can
right on.
tell the developers that, hey, this code push actually broke the system. He or she would be much more happier than looking at a trace and trying to, what's going on?
So just.
Wait, but
Can I just-
people walk out because
Okay, yeah,
they're
please.
supposed to be. Anybody who wants to stay and ask more questions and talk.
And so we have a couple of scheduled slots already, so if you've emailed me and I've given you a time, we're approximately keeping those. So that'll be in the conference room on the 13th floor, 1324, and if you're interested in grabbing some additional time, please invite me.
You guys thought you were going home, you're staying.
Just one quick thing. So we had this MOC Alliance there. We're gonna have a whole bunch, we have a large scale, probably up to 400 or so servers by this summer. OpenShift, large scale OpenShift environment. What can we do to, like in terms of providing both a place where not only researchers here can do things, but what you would like to see from the cluster, where everything can be very open, where things can evolve quite quickly. Obviously, these are production services, research IT production people are staying them. We can't affect the correctness of the service, but we can certainly affect both the telemetry and having guide tools sitting on the side that can show the value of real alerts
Right,
and stuff
yep.
like that. You know, I just would ask you to, you know, this, I think is a unique place where you can do things totally open. Let us know if there's.
Yeah, no, I think let's pick up one service and let's focus on it and get something going. I think it's very much possible.
Yeah.
It's very much possible.
So,
Thank you very much.
All right, thank you. Thank you.
yeah. And if it's not obvious, one thing we could use is better monitoring of time.
Yeah.